Hello and welcome back to my channel once again. This is your man Alan, and in today's tutorial we shall be looking at the three set problems regarding to Venn diagrams. So as you can see on the screen here, we have the three set problem. A set is a collection of like objects. So in this circle we can term it as circle A, and this circle B, and this is circle C. Each of these circles contains a particular set of items which are identical. So if they are not identical, you can't put them in one group or one set. The elements or the members must be the same to classify that thing as a set. Okay, so we shall be dealing into it very much. So the first part, which is to say that when I pick this area, it comprises of B, that is B, and then A only. So it means C is not part of them. So you rule out C. But when I look at A intersection B, I'll be looking at the whole of this area. Okay, but only A and B is this side only. Now the middle one here contains A, it contains C, it contains what? B. So that is this side, and that we call A intersection B intersection C, which is this small area. Now this area here is also B intersection C, B intersection C, and in that area too we can get B intersection C only. So it means A is not part, so that will be this side, and then A intersection C only will be this side. Now the whole of this rectangle represents the universal set, and the universal set is the mother set of all the other sets. All subsets comes out of the universal set. Okay, so everything inside this rectangle is referred to as the universal set. So when you sum everything in the rectangle, it must give you the value for the U here. Okay, so without much ado, we shall continue and take some little examples that can help us to comprehend this topic very well. When you follow tune to the end, you will find it that three set problem is very easy and simple to deal with. Now, the first thing we want to look at is a definition of a Venn diagram. So a Venn diagram is a diagram that uses circles to illustrate the relationship among sets. So here I've used circles, but it could be any other diagram, rectangles or any other plane figure that you can use to illustrate the relationship among some sets. Okay, now we can further say that a Venn diagram, it was invented by a guy named John Venn, and that's how come the name came Venn diagram. So his name was Venn, John Venn, as a way of picturing relationship between different group of things, and this different group of things is what referred to as the set. So one group have identical members, and the other group have other identical members. So he was trying to find the relationship between them, and since the mathematical term for a group of things is a set, we call it the Venn diagram can be used to illustrate both set relationships and then logical relationships. So because this group, like I said, are set, then we use the Venn diagram to illustrate these relationships that exist between the different sets. So it could be two sets, it could be three sets, and it could be more than that. But at our level, we shall be dealing with only the three set problem and the two set problem. So the two set problem, you have done that in the basic school, that is in the junior high school. And the SHS, you have done revision on the two set problems, and you'll be doing the three set problem. All right, so that is a brief history about how the name Venn diagram even come to being. So John Venn was the originator of what? The Venn diagram. And that's how it was named after him. Okay, so we go further. Let's say that our universal set contains the numbers 1, 2, 3, and 4. When we talk about the universal set, like I said earlier, the universal set is a set that housing all the other sets. All the other subsets comes out of the universal set. So the universal set we take here is 1, 2, 3, and 4. And now let's say there's a subset A to be the set containing the numbers 1 and 2. So A is a set 1 and 2, and a set is denoted by what? Curly bracket. So we use the curly bracket to illustrate a set. This means set of, so set of, when you see the curly bracket, it means set of 1 and 2. They are like numbers, they are all numbers, so there is a set. And 1 and 2 can be found in the universal set. So therefore, A is a subset of what? The universal set. Now let B to be a set containing the numbers 2 and 3. That is, B is equal to a set of 2 and 3. And these numbers are also from what? The universal set. So therefore, B is also a subset of the universal set. Now then, we have the following relationship with pinkish shading. So we are putting some shading on it so that you get to understand it more. We want to get the relationship that exists between these two sets. That's why we said that the Venn diagram seeks to explain the relationship that exists between two things or set of group or set. Okay, so we want to get the relationship that exists between the set A, B, regard to what? The universal set. Okay, so the shading makes the solution regions in the Venn diagram. What we have shaded is the solution to the Venn diagram. Now the first thing we want to look at is A union B. Remember, A union B. A values was what? 1, 2, and B is 2, 3. The union means you put together, so 1, 2, and then 3. Now when you are using the union, when the number repeats 2 and 2 here, you don't repeat it, you write only to once. So A, this symbol means union, so A union B, that's how you pronounce it. And it means everything that is in either of the set A and B. And then we can illustrate it as 1, 2, 3. So set A, let's say it's here. 1, 2 is in set A. 2, 3 is in set B. 4 is part of the universal set, but it's not inside A, it's not inside B. So therefore, we just put it in the rectangle, any place that is not shaded. But now we are looking for A union B. So we shade A, the whole of A circle and B circle together. And that is 1, 2, 3. We are putting the A elements and the B element together. But like I said, we don't repeat the numbers. The next one is A intersection B. Intersection here means the things that are in A and are in B at the same time. So only the things that are in both of the set. That is, you see that 2 is in A, 1, 2, and it's also in set B. So we pick 2 as what? The intersection. So intersection is the numbers that appear in both set A and in set B. We pick those ones. So here we have only 2 appearing in both of them. Now, the next one was that A complement. So A exponent small c or prime. You can put a prime figure there like this. Or minus, something like a minus A, okay? And we call it the complement of A, or not A. So this symbol means not. The symbol you are seeing here means not A. Now everything in the universal set outside of A. So anything that is in A, that is 1 and 2 is in A, we just pick it out. But any other element which is not in A is also referred as the complement of A. 3 is not in A, 4 is not in A. Therefore, the complement of A will be what? 3 and 4 as stated here. So let me use the diagram to show you more. So everything in the universal set here, aside the A, is the complement of A. A contains 1 and 2. Aside that, what else is in the universal set? That's the shaded region. Okay. Now the next one, that is A minus B. That is A minus B. or A complement B. A complement. So you are taking A and you are taking away what? B. So let's do that. It can also be that A only. So this is A. The whole of 1 and 2 is A. 2 and 3 is B. So we are saying that A minus B. So you remove the whole of B. It's not shaded, but you only shade what? A. You only shade this part. Remember, 2 is in B, so I don't shade it. Okay, so A only is only one that is in A. That's the meaning of A minus B, or A is in B complement, so B is not part of it. Okay, now we have A union B complement, all complement, which is not A union B. So you first find A union B, and those that are not in A union B, that is what we are looking for. So everything outside A and B. So realize that A union B, A union B, we have A, 2, A, that's 1, 2, and then B is 2, 3. Anything outside this is what we are looking for, not A union B. It is not A union, so it can be what? A union B, all complement. The things that are not in A and B, in the other way. So A union B complement, all complement. That is what we meant here. Okay. Now the last one is A intersection B complement. So A intersection B complement. So here is A union B complement. This is what? A intersection B complement. And now union means you combine A and B. And whatever is not inside that list, then that is the rest. So 1, 2, 3 is A union B. Then what is outside? What is not inside there? It's only 4. So we shade that area. Okay. Now when we come to the intersection, what is the intersection is 2. So the rest that are there, the rest that are left is what you shade. So just look at this diagram. The intersection is this. So A intersection B all complement. So here is 2. What is not inside here? 1, 4, and 3 are not inside the intersection. So we shade that area. So therefore, A intersection B all complement, or not A intersection B, is 1, 3, and 4. B are not inside the A intersection B. Alright, so you can pause the video and go over it again. But don't forget to hit the subscription button and the notification button so that when I release any other new video, you will not be left out. Alright, so we proceed with these beautiful diagrams over here. So the first 2 circles is what refers to as the 2 set problem. So you can realize that we have the set A and the set B. There's 2 different circles or 2 sets. That is how come we call it a 2 set problem. So once the set problem contains 2 sets, we refer to as the 2 set problems. And once it contains 3 sets, we say about 3 set problem. Now in the A and B, the intersection is this. Means A intersection B. This region contains both elements belonging to A and also belonging to what? B at the same time. So that is this region. And when you come to this A intersection B intersection C, it means the element that belongs to A, B, and C at the same time. A intersection B here is B, A intersection B only, this region. It means C is not part. When you come to this, A intersection C here means A intersection C only, B is not part. So you know C, B there. And this one means A is not also part. Okay? A here means it's only A. You know C, B, you know C, C. This place represents elements only in A, elements only in B, and elements only in what? C. Note the preamble or the keyword is only, alright? But when you hear all, it means you are talking about the intersection of all of them, alright? Now we proceed to take some level example in shading some of those regions. So this is just to make us able to identify how we can represent information in the Venn diagram. in order to aid us solve it very easily. Now we want to shade the region A union B minus A. So B minus A, trying to say that B and A, C, remove C away. That is B intersection C complement. B intersection C complement. You are removing C away. Okay. So as usual, when faced with parentheses or a bracket, we usually work from the inside out, just like both mass. You start from the inside. You deal with B minus C before you proceed to take the union of A. So I will first work the B minus C. That is, I say B complement of C. So mean I take B and then throw out its overlaps with C, which gives me this diagram over here. So this is B and this is A. This whole circle is C. This whole circle is C and this whole circle is what? B. So I remove C away. You cut the whole of C away and leaving what? Only B. Alright? That is, I have dealt with the bracket B minus C. So B, you remove the C away. Okay? Now I will now union it with the A here. Take the union of it with the A. Then we see it's very beautiful over here. So A is the whole of A. And when we say the union, it means you are putting it together. So I'm now taking B minus C, which is from this region, and I'm unioning what? A. So union means to put together, to add all of them together. Okay? So I'm now unioning with the whole of A. Put the whole of A together with this. And that is how you represent this. So A union B minus C is this. Okay. The next one is I want to say the region B union C all minus A all bracket complement. So this is not. So you first find B union C, you subtract A out of it, and you take the rest that are not in this. Is what we are looking for. So it's like saying B union C minus A all complement. Okay, all complement. That's what we are looking for. The same as this symbol, not in it. Or B union C all complement intersection A. That is the same thing. So when we are dealing with this like nested grouping symbols, I would like to work from the inside out, like the first one we did. So here we have two parentheses, different parentheses over there. So B union C. B union C means you combine B and what? C together. That's the first step, the first bracket. Now you remove A away. So I'm going to remove the whole of A away in the next one. So I'll remove the whole of A out. So A is not part. So I've dealt with the inside. Now, what are the rest that are not part? You can see that all the other region that is not shaded is not included in B and C. So that's the region we are looking for. So we shade the opposite of it. So the not complement with the filled says to reverse the shading. So I'm now going to shade the whole of that place. Okay, so the first one we look at is what? We first find B union C, which is B union C minus A. I'm going to take A away. A. So A starts from A. This is the whole circle, the whole of this circle. I'm going to take the whole of this circle out. It's not shaded. So that's how come we have the whole of this circle, which is out of the story. Now, after that, we are seeing the complement of this. The complement of this, and we say complement are the things that are in this set we have just found, but are not in the universal set. So they are here, but they are not in the universal. So they are from this to that. What are the things that are not inside B and C? It's the unshaded place, and that's what we are now looking for because of this symbol. They are not inside here, so we shade all those places, and that becomes our result. You can pause the video once again, like I said, and go through it at your own pace. Now I want to take some examples real life situations that can help us to better comprehend what we are doing over here. So, example of Venn diagrams. Now we have dealt with the shading. Let's look at how we can apply it. The Venn diagram below shows the numbers of grades. So this is the diagram. It shows the number of grade 5 students who score above 50% on math, above 50% on science, and above 50% on both math and what? Science. So this circle here represents the math, and this circle represents what? The science. Now, you should know that the class is the grade 5, so it can be primary 5 or whichever it is. So, those who passed above 50% on math, we have them as what? 16, because 10 plus 6, that gives me 16. And those who pass above 50% on English, also the same, add 6 plus 15, that will give me 21. Now, those who scored both above 50% is only 6. Those who scored both is 6. Okay. Now, with this the same Venn diagram, 10 of the math students only scored above 50% in math. 10. There were only 10 who scored above 50% in math, and there were only 15 who scored above 50% in science. Okay, but 6 also scored above 50 in both of the subjects. So when you are calculating those who scored above 50% in math, those who scored in both will be part of the 10. That will make it the 16. Okay, and then likewise with that of the science. Now, from the Venn diagram, like I have just explained, we learned that 10 students scored above 50% on math, 15 students scored above 50% on science only, and 6 students scored above 50% on both math and what? Science. And then we can take another one. So this other one illustrates that out of 40 students, 14 are taking English composition and 29 are taking chemistry. If 5 students are in both classes, how many students are in neither class? How many are in either class? Look at the keywords very well, neither and either. So what is the probability that a randomly chosen student from this group is taking only the chemistry class? Now, the first thing is to represent this whole information into a simplest form. We can say that let U be the number of students in the class, let E be the number of students taking English, let C be the number of students taking chemistry, and then maybe the intersection and all that. Please, you take your time, go through it, and that one they have taught you already, but I'm just here to let you know how you are going to put these things in the Venn diagram to understand them very well. So after you have done that, you draw the Venn diagram and you put this information inside. Now, after drawing the Venn diagram, you realize that you first search how many subjects are they talking about. We have only English and chemistry, so which are 2 basic subjects. They are not 3 different subjects. Therefore, it's not 3-set problem. It's a 2-set problem. So I have English and then chemistry. That's the first thing you have to note before you draw the Venn diagram, to know that it's 2-set problem or 3-set problem. So in our case, it's 2-set problem. Now, out of this, 14 of the students studied what? English. So this circle is what? 14. Then 29 takes chemistry, so 29 is over here. Then if 5 students are in both classes, so 5 students are in both classes, so which is the intersection over here, 5 students. Now, whatever that is inside the circle must give me what? 14. So if 5 is already here, then the remaining here is 9. And 9 here means those who are in the English class only. So English class only is 9. But out of the 14 students, there are 5 students who are in both English and what? Chemistry. So when you combine 9 and 5, you get what? 14. All right? So remember, when you add everything in this cycle, you must get 14. Now here too, we have 29 as those taking chemistry. But out of this 29, 5 are doing both. So therefore, what is left that are doing only chemistry is what? 24. Okay? 24. Now, the next thing we got to look at is the thing is 40 students, the universal set, number of students in the school or in the class or whatever it is. But their total is what? 40. Okay? Then, the first question that was asked, now, how many students are in neither class? How many students are in neither class? So the neither here is talking about how many students are not in English class nor in chemistry class. But they are in the universal set. They are part of the 40 students. But they are not inside English class. They are not inside what? Chemistry class. So what you have to do is that we add all those inside these classes and take it out of 40, because the total, if you add everything inside here, it must give you what? 40. So we drive the formula as you take the universal set and add whatever that is inside these circles, and then you subtract it from 40. So the universal set is 40, and when I take 9 plus 5, that will give me 14, and 14 plus 24 give me 38. So you take 40 minus 38, and that is 2. So 2 students are not in any of the classes. So either they are doing a business or any other course, but not what? English and chemistry. Now, look at this formula here. We have used E, number of English and number of chemistry together. You add this and add this. Now, when you are adding English and chemistry, note that those who are doing both will be repeated. So 14 plus 29. In this 14, there are 5 students who are still doing chemistry. In the 29 here, there are still 5 students who are doing chemistry. So it means the 5 is going to be repeated. So you subtract the intersection. So when you take 14 plus 29, that will be giving you 43. And 43 minus 5 will give you 38. Please pause the video and try to comprehend it. So 38. Now you take 40 minus 38, which will still give what? 2. All right. Now, the next question is that how many are in either class? So how many students are in English or chemistry? They are in either class. They are in any of them. So you just add all of them together. They are in either classes. So we have these 9 students, 5 students, 24 students. They are in either of the classes. Okay. In other question, they may ask you how many students are in English or chemistry class. The order is the same as this statement here. Can also be how find E union C. Union C. So you are still combining the 2 circles together. So 9 plus 5 plus 24, that gives me what? 38. So which is just like taking this. So I just take this plus this, which means this one is doubling up. So I subtract the 5 out, leaving 38. Or just take what? 9 plus 5 plus 24, which is still what? 38. Because you are looking for those who are in this circle, this circle. So 9 plus 5 plus what? 24. And that will give you 38. Now, the last part of the question is saying that was to find the probability that the randomly chosen students from this group is taking only chemistry. Now, only chemistry here is 24. Remember, 24 here is only chemistry. 5 students were taking both English and chemistry, which were part of the 29. But we have to take the 5 students out, leaving 24. And these 24 students only takes chemistry. All right. So we are looking for the probability of these students, and probability is the likelihood of a particular event happening. So what's the likelihood that 24 students takes chemistry? So you put it that way. So it means it's going to take 24 out of what? The total number, which is 40. What's the likelihood that 24 students out of the total population in the school takes chemistry? So we take 24 over 40, and that'll give me 3 over 5. Now, one thing you should know that probability does not exceed 1. It lies between 0 and 1. When it is 0, it means the event cannot occur. It can never occur. When it is 1, there's a surety that the event must occur. It must. So that is. But when it is falling between 0 and 1, then it becomes more of a probability. It is either happening or it is not happening. When it is 0.5, that is 50-50. It either happens or it not happens. Depending on the degree of the probability will depend on how the event will occur. So if I have 0.9, it means the likelihood of the thing occurring is higher. Okay, that is the probability for you. But we are dealing with set, so I will not go deep into probability. That will be another lesson to look at. Please don't forget to hit the subscription button and the notification button so that you keep on track when I release any new video. Now we take another example. Fill in the Venn diagram that would represent this data. The data is that 100 people seated at different tables in a Mexican restaurant were asked if their party had ordered any of the following items: margaritas, chili, con queso, or quesadilla. 23 people had ordered none of these items. 11 people had ordered all 3 of these items. And then 29 people had ordered chili or quesadillas, but did not order margaritas. 41 people had ordered quesadillas. 46 people had ordered at least 2 of these items. 13 people had ordered margaritas and quesadillas, but have not ordered what? Chili. 26 people had ordered margaritas and chili at the same time. Now, looking at this, we are saying that all the 3, we have been mentioning 3 different items. So which means that we are talking about 3 set problems. So you first break your data down into smaller pieces which you can deal with, and now you draw the Venn diagram for your data. So we have the first circle as the margaritas, and then the quesadillas, and we have the chili con queso. These are the 3 different circles or sets that are there. So this one contains a set of people who ordered for this particular items. This also contains those who ordered for quesadillas and those who ordered for chili con queso, and this is also here. Now let's take our time and explain how I have been able to fill in this data for you to understand it. First of all, it says that 100 people seated at the different tables in the Mexican restaurant. So the universal set here is 100. So the universal set here is 100. So everything inside this diagram or Venn diagram is what? 100. So you should take note of that. Now out of these, let me go ahead. 23 people had ordered none of these 3 items. So the 23 people, they are not in this. They didn't order for margarita. They didn't order for quesadillas. They didn't order for chili con queso. So, but it is inside the universal set. They are also part of the people, the 100 people. So we put it in the Venn diagram, just the rectangular part. So that's why we put it outside here, because they don't belong to this. They don't belong to quesadillas, and they don't belong to chili. All right. Now, 11 people had ordered all the three. So 11 people have ordered all the three, and that is this region. 11 people have ordered all the three. Why is my cursor misbehaving? That is only this place. Okay. Now we go ahead, and that 29 people had ordered chili, conguiso, or quesadillas. And I explained earlier on what all means. All means we are putting them together. Okay. So 29 people had ordered chili, conguiso, or quesadillas. So you are adding chili and this one together. So that is the whole of this circle and the whole of what? This circle. But let's continue. It says that but did not order margaritas. So it means the whole of this other circle is not part of the story. So the whole of this one is not part of the story. So it's only 10, 7, and what? 12. So I add it, and you must give what? 29. So that is 12 plus 7 is 19 plus 10, that's 29. It goes further to say that 41 people had ordered quesadillas. 41. So here it's trying to say that 41 students ordered for this. So the total people who ordered for quesadillas are 41. The whole of this cycle must give you 41. So if you add 13 plus 11, that will be 24 plus this 31 plus 10, that is 41. The whole of this circle. So when you finish and you sum them up and it is not 41, then your information input in the Venn diagram is wrong. Again, 46 people had ordered at least 2 of these items. When you say at least, it's either 2 or more items. They have ordered 2 or more items. So 9 here only ordered for margaritas, it's only 1 item. 10 here only quesadillas, it's only 1 item. And then chili here is only 12. But those who ordered above, 15 here ordered both margaritas and what? Chili. Likewise the 13 and then 7. 11 here, they ordered all the 3. So it means also above what? 2. Now, I'm just putting that they said at least when you hear the at least 2 of the, they are talking about this region, and then the third region. But except they say that at least 2 of the items only, and they say the only, it means the third part, that is 11 is not part. But now they're saying that at least just 2. Okay? And when the word at least comes in, so it means you can order more than 2, but you can't order less than 2. That's why we have to add 15 plus 13, which is going to be 28, plus 11, that will be 39, plus 7, that gives me 46. You see that? So when you sum these and it's not 46, then your information put in the Venn diagram is wrong. Now, 13 people had ordered margaritas and quesadillas, but had not ordered chili conguiso. So 13 students. So 13 people. So we have quesadillas and margaritas. So first look at this one and then this one. And you look at this and this. Which one are they talking about? We have margaritas and quesadillas. So it means they are talking about this circle and this circle. Now, how many ordered for it? It said 13 ordered for margaritas and quesadillas, but not chili. So you take chili out of the storyline. So this place is not part. So it means the 13 is coming to only margaritas and what? Quesadillas. This portion. We have done shading of this in the previous part. So you should know that when they say not, it means this area is not part. Chili is not part of the margaritas and quesadillas. So it's only 13 that is landing inside here. Now the last part of the question says that 26 people had ordered margaritas and chili. So 26. margaritas and chili. So we have those ordered for margaritas and chili. Now remember, it didn't say only or but not this one. So the whole of this region is margaritas and the whole of this region is chili. So where is their intersection? Their intersection is here. So when you sum this up, they should give what? 26. So 15 plus 11 should give me 26. So when you don't get that, it means your item is wrong. So take your time and go through the video. You can pause it and listen to it over and over until you understand it. All right. The next example is that you want to represent this data on a Venn diagram. A study was made of 200 students to determine what TV shows they watch. So 22 students don't watch these cartoons. Okay, 73 students watch only Tiny Toons. 136 students watch Tiny Toons. 14 students watch only Animaniacs and Pinky and the Brain. 31 students watch only Tiny Toons and Pinky. 63 students watch Animaniacs, and then 113 students do not watch Pinky and the Brain. So pause the video and try to see if you can take this as well. Draw a Venn diagram first of all. So we first outline this subjects that are inside the TV stations that are inside there. So first we have Tiny Toons, and we have Animaniacs, and we have Pinky and the Brain. So these are the three different TV stations or TV shows that they watch. And these TV shows are put inside this Venn diagram. So there are three different TV shows, and that makes what? Three-set problem. Okay? And in this, it is saying that the universal set, the number of students that were there is 200. So 200 students. So we have the universal set as 200. And then 22 students don't watch these cartoons. 22, they don't watch any of them at all. And that's why you are seeing it in this region here. They don't watch any of them. No. They are not inside Tiny Toon. They don't watch it. They don't watch Animaniacs. They don't watch Pinky and the Bear and the Brain. So it's not the end of this cycle, but it's inside the universal set. It's part of the students. So 22 of them, I believe they don't like watching cartoons and things. So they like football and Chinese and matter. Okay, that is by the way. So aside that, 73 students watch only Tiny Toons. 73 watch only Tiny Toons. So when we outline only Tiny Toons, just circle all the other TV shows out. So circle the whole of Animaniacs and the whole of Pinky, the Brain out, and the region that is left is what? Only Tiny Toons. So 73 of them. So that is this region over here. Now 136 students watch Tiny Toons. 136 watch Tiny Toons. So the whole of this cycle, the Tiny Toons, they should sum up to 136. You can pause the video and sum that up and see whether you get 136. You take 73 plus 23 plus 9 plus 31, and you must get what? 136. The next says that 14 students watch only Animaniacs and Pinky. So 14 students watch only Animaniacs and Pinky. So just rule out Tiny Toons because they're talking about only Animaniacs and Pinky. They didn't mention Tiny Toons, so just rule out that whole circle. So the whole of this circle is out. But they are saying they are watching Animaniacs and Pinky here. So they are talking about their intersections, which is here. So this is a way of being able to fill your Venn diagram very easily. They have not mentioned Tiny Toon. They said 14 students watch only Animaniacs and Pinky and the Brain. So Tiny Toon is not there. So just rule out this whole circle, and you realize that you have only this region. Now they are talking about the intersection of Animaniacs and Pinky and the Brain. So which is 14. We just put it here. All right. Now we go ahead. 31 students watch only Tiny Toons and Pinky and the Brain. So they didn't also mention Animaniacs. So you also rule out what? Animaniacs. Rule out this whole circle, and you see that you only have this. And they are talking about the intersection, which is 31. Next, 63 students watch Animaniacs. So 63 watch Animaniacs. So when I sum everything inside this circle, which represents Animaniacs, it should give me 63. Okay, so the number of Animaniacs is 63. So I have 23 plus 9 plus 14 plus 17. That will give me 63. Now 113 students do not watch Pinky and the Brain. Pinky and the Brain, they don't watch it. So just remove the whole of Pinky and the Brain. The rest that are left is Tiny Toons and then Animaniacs. So if they are saying that 113 students don't watch Pinky and the Brain, just rule out that, and the rest that are left, they are those who don't watch them. So those who watch Pinky and the Brain are the 31, 9, 14, and then 11. Sum them up and take it out of the total. That's 200, and you get the result. So 200 minus the total of this. Okay, that is one of the way of getting it. Or just use your hand to close this whole circle. That's the Pinky and the Brain. And then you sum up 22 plus 73 plus 23 plus 17, and you're going to get 118. All right. Fill in, but before then, remember the 22 here is not doing this, but in our preamble earlier, we said that 22 of them do not do not watch any of them. So 22 years out. Okay, so it means it's only 73 plus 23 plus 17 that will give you the 130. Sorry for that. So take note of it. These 22 people, they don't study, they don't watch any of them. So definitely they are not part of even any of them. And now we are taking Pinky Brain also out. The rest that are left is what? The 73, the 23, and then the 17. So 73 plus 23 is going to give you 96. And then the 6 plus 17 is going to 130. Okay. Let's exactly. Let's take that correction and continue. The next one we're going to look at this is saying that 150 people at a hangout with Jesus were asked if they knew how to play piano, drums, or guitar. Look at this. How many elements we have, or set we have? We have piano, drums, and guitar. So it means there are 3. So we have a 3-set problem. So 18 people could play none of these instruments. 18. 10 people could play all 3. So just be outlining them as I read. 77 people could play drums or guitar, or some, but could not play piano. 73 people could play guitar or guitar. 49 people could play at least 2 of these instruments. So they could play either piano, drums, or guitar. And 13 people could play piano and guitar, but could not play drums. So these 13 people can only play piano and guitar, but they can't play what? Drums. So 21 people could play piano and drums at the same time. Now let's draw a Venn diagram. And piano represents this circle, drums represent those who play, and then those here represent those who play, who can play guitar. So we now start to represent everything inside. 150 is a universal set, the number of people who went out for the hangout with Jesus. So So if you sum everything inside this rectangle, everything here is to give you 150. If it exceeds or less, then it means there's a question mark with your solution. Now, out of this 150, 18 people could play none of these. So none of piano, it is not inside piano, it is not inside those who play drums, it's not inside those who play guitar, but it's part of the whole universal set. So that's why we put it over here. Alright? Now, 10 people could play all the three. So all the three, that the intersection is here. 10 could play all these three. Play piano, drums, and then guitar. Just rule them, rule, and you see the intersection is 10. Now, 77 could play drums or guitar or guitar, but could not play piano. So we have drums, we have guitar, but they can't play piano. So we rule out the whole of piano. They can't play piano, so just rule it out. Okay? But I think 77 of them. So when I add 35 plus 15 plus 27, it should give me 77. It should give me 77 because 77 people could play drums and guitar or guitar. So they all be in sum. You sum them, and that will give you 77. Okay. Now, 49 people could play at least 2 of these instruments. So I said when you hear at least, they are talking about these 3 regions plus the middle region. So 1, 2, 3, 4. These 4 regions. 1, 2, 3, 4. So it means they either play 2 or they play more, but they can't play only 1. Okay. So these 11 people here, they play 2. They play both piano and what? Drums. So you add this 11 plus 13 plus 15, and that is going to give you 49, which is this 49. Okay, so 49 people could play at least 2 of these instruments. So when you don't see at least here, you don't see the at least here, but you hear that 49 people could play 2 of these instruments. 2 of these instruments. So it means the third region. These people, they play 3, they don't play 2. Okay? 49 people could play 2 of these instruments. So it means we are only summing 11, 13, and 15. But the moment you hear at least, it means it could be 2 or more. That's why you have to add the third region to it. Okay? So try to pause the video and look at it into details. Now, the next one says 13 people could play piano and guitar and guitar, but could not play drums. So you rule out drums. Those who could play piano and guitar, but they can't play what? Drums. So rule out of the whole of drums. And the rest that are left, they say what? 13. So that's how come we have this 13 inside this place. Piano and guitar. Piano and guitar intersection. The intersection could have been the whole of this place. Okay? But that's the intersection of piano and guitar. But they are saying that they don't play drums. They can't play drums. So this region is out. This region is out. So it means it's only what? This place, which is piano and then guitar. That is the 13. 21 people could play piano and drums. 21. So look at here. It's saying they can play piano and drums. So what is piano? Is the whole of this place. And then drums is also the whole of this place. So that's the whole of the section. So here they didn't specify whether guitar is part or not. So it's, when you sum everything inside here, it should give you 21. So 10 plus 11, that gives you what? The 21 here. Alright? So that is how this information is supposed to be presented on the Venn diagram. But like I said, the moment you see the question, you have to first outline the thing. Let U be the number of students or people who went out for the hangout with Jesus. You have to define your terms before you now put inside the Venn diagram. That will be more easier, and those ones sometimes attract marks. Okay? And the next one is I want to say that people who could play none of these instruments, let 18 people be the number of students who could not play any of these instruments. That is, let P intersection D intersection G all complement is 18. All complement is 18. It means they don't play any of them. They are not in any of these. Okay? Or you can say P, that's P for piano, D for drums, G for guitar. P union D union G, all complement. All complement. So those that are not inside this is what? The 18 people. So you can go through it more. In my next video, we will be looking at how we can work it into details. This one, we are just looking at how we can represent this on the Venn diagram. So in my next video, we'll look at how we can solve these practical questions step by step for your understanding or comprehension. But at least this one has given you an in-depth of how you can represent the things on the Venn diagram. If you're able to do this, all the questions asked here, you can be able to answer. All right? Thank you for watching. Don't forget to hit the subscription button and the notification button once again, so that when I release any other new video, you'll not be left out. Have a nice time.